Welcome back, everybody, to another deep dive.
Yeah.
And today we're going deep into a world that's teeming with bacteria.
Yeah.
A world that you might not even realize is closer than you think.
Mm-hmm.
We're talking about biofilms.
Biofilms. You know what's fascinating about biofilms is that they're not like this rare phenomenon.
Right.
They're incredibly common. In fact, a staggering 90% of bacteria don't just float around freely.
Wow.
They actually exist in these complex communities,
Okay.
clinging to surfaces,
Okay.
especially in water systems.
90%.
Yeah.
That's way more than I ever imagined.
Yeah.
So are these biofilms like underwater cities for bacteria?
That's a great way to think about it. You can imagine a bustling metropolis,
Go.
but instead of towering skyscrapers, you have this intricate structure of bacteria
Right.
encased in a protective slime that they produce themselves.
Oh, wow.
We call this slime EPS, or extra polymeric substance.
APS.
Yeah.
Okay, so that's their secret weapon.
Exactly.
Oh.
This EPS shield is incredibly ingenious. It makes the bacteria up to 1,000 times more resistant to biocides,
Wow.
the very chemicals that we use to try and eliminate them.
Right.
And this is why removing these biofilms
Yeah.
is a far greater challenge than dealing with those free-floating bacteria.
So we've got these biofilms, these bacterial fluntrices,
Yeah.
and we're trying to combat them with biocides.
Right.
But are we winning this war?
Well, it's not a simple battle. It's more like a strategic game of chess. First, we need to understand the different types of biocides. So there are oxidizing biocides,
Okay.
or OBs,
OBs.
which are like the heavy artillery. Strong and fast-acting chlorine and ozone are classic examples.
So OBs are effective, but I'm guessing there's a catch.
You got it. Think of it like using a powerful cleaning agent. Sure, it gets the job done, but it might also damage delicate surfaces.
Yeah.
In the same way, OBs can be corrosive
Right.
and sometimes create unwanted byproducts.
And these OBs, they're not just targeting bacteria, right?
Bro.
They react with other things in the water, too.
Exactly. OBs don't discriminate. They react with a lot of different substances in the water,
Okay.
which leads us to this important concept called oxidizing demand.
Oxidizing demand.
Yeah. This basically tells us how much of that biocide
Right.
is being used up by reacting with everything else
Right.
before it can even reach the bacteria.
Interesting. So in your system, some of the chlorine you add is being used up by other stuff before it can even reach the bacteria.
Exactly.
Okay, so that brings up a crucial question.
Yeah.
How do we even know if our biocide treatment is working? I mean, we often measure residual chlorine,
Right.
but is that enough?
That's where a common misconception comes in.
Okay.
Many people believe that if they measure leftover chlorine, that residual chlorine,
Right.
their system is automatically bacteria-free,
Right.
but that's a dangerous myth.
Wait, really? I thought if there's chlorine left, it must have done its job and killed all the bacteria.
Not necessarily. Residual chlorine only tells you how much chlorine is left, not how many bacteria were actually killed. Imagine you briefly treat a stubborn biofilm with chlorine. You might still detect residual chlorine,
Okay.
but the biofilm itself could be largely intact. Those bacteria are still thriving within their protective EPS layer.
Oh, so you can't just rely on chlorine levels. You need to know what's happening with the biofilm itself.
Precisely.
Okay.
And that's why relying solely on residual chlorine measurements
Yeah.
can give you a false sense of security. It doesn't tell the whole story. You need to monitor the biofilm directly.
Okay, so biofilm monitoring, that's the key. But why is it so crucial, and how do we even go about doing it?
Biofilm monitoring gives you real-time insights into
Uh-huh.
how effective your sanitation treatment truly is. Think of it like having eyes on the battlefield,
Yeah.
allowing you to adjust your strategy as needed. You wouldn't just fire blindly into the darkness.
Right.
You need to see what you're dealing with to fight effectively.
This is making me think about all the different places biofilms could be lurking.
They're more common than you might think. They thrive in all kinds of environments,
Yeah.
from cooling towers and drinking water systems to food processing plants
Yeah.
and even our own homes.
So we've got these biofilms, they're everywhere. We know residual chlorine measurements aren't enough.
Right.
What are our weapons in this fight?
Well, we've talked about OBs, but there's another type of biocide,
Okay.
non-oxidizing biocides, or NOBs. These are more like snipers, gentler on the system itself, but can be slower acting.
Okay.
QOTS, or quaternary ammonium compounds, and isothiazolinones are common examples.
So OBs are the heavy artillery.
Yeah.
NOBs are the snipers.
Right.
It seems like choosing the right type of biocide is pretty tricky.
It definitely requires careful consideration. You got
Yeah.
to factor in things like the specific application, the
Right, yeah.
pH levels,
Hmm.
the temperature, and even the materials of the system itself. There's no one-size-fits-all solution.
This is starting to feel like a complex puzzle, and we've only just begun to scratch the surface. So we've got our heavy artillery, the OBs, and our snipers, the NOBs.
Right.
But is it as simple as just choosing one or the other?
Not quite. It's about understanding how these different types of biocides can work together.
Okay,
One effective strategy is to actually combine OBs and NOBs,
good.
using their strengths to overcome the challenges of those stubborn biofilms.
So it's like a coordinated attack using both brute force and precision.
Exactly.
Yeah.
Think of it this way. OBs, with their powerful oxidizing action,
Right.
can break down that tough outer layer of the biofilm,
Okay.
that EPS shield we talked about.
Mm-hmm.
This creates pathways for the NOBs to penetrate deeper
Right.
and target the bacteria hiding inside.
It's like a 1-2 punch.
Yeah.
Weakening the defenses and then taking out the enemy within the...
Yeah.
Are there any situations where this combined approach might not be enough? What other weapons do we have in our arsenal?
That's a great question. There are situations where we need even more advanced weaponry.
Okay.
That's where advanced oxidation processes, or AOPs, come in.
AOPs. Tell me more about this cutting-edge technology.
AOPs take biocide power to a whole new level. They generate highly reactive molecules, like hydroxyl radicals,
Right.
right at the site of the biofilm.
Wow, so it's a super precise attack.
Yeah.
No collateral damage.
Well, the impact on the surrounding environment is minimized,
Okay.
which is a huge advantage, especially in sensitive applications like drinking water treatment. However, AOPs can be more complex
Right.
and expensive than traditional biocide treatments, so
Right.
they're not always the first choice.
So we've got our biocides, but we also need our intelligence gathering, right?
Right.
That's where biofilm monitoring comes back into play.
Absolutely. Monitoring is crucial for understanding not just IF biofilms are present, but where they're growing and how much is there. That's where continuous real-time monitoring is so valuable.
It's like having a security system that alerts you the moment a burglar breaks in.
Oh.
You can respond immediately before things get out of control. What kind of technologies are used for biofilm monitoring?
There are various techniques. Some involve using sensors that directly measure the thickness or activity of the biofilm.
Okay.
Others utilize imaging techniques to visualize the biofilm structure.
Okay. So we're not just blindly throwing biocides at the problem anymore. We're gathering intel, strategizing, and targeting our attacks.
Mm-hmm.
But even with all these advancements, isn't biofilm formation a natural process? Can we ever truly win this war?
That's the challenge, isn't it?
Yeah.
Biofilms are a force of nature. They've evolved over billions of years to survive, to thrive in all sorts of environments. But while we may never completely eradicate biofilms,
Right.
we can certainly learn to manage them effectively.
And that means shifting our mindset from a reactive approach to a proactive one.
Exactly. It's about prevention as much as it is about treatment. Designing systems that minimize biofilm growth is essential. Think smooth surfaces,
What?
high flow rates,
Huh.
and proper temperature control. We need to make the environment less hospitable to those bacterial squatters.
So it's like fortifying our defenses and making it harder for the enemy to establish a foothold.
Yeah.
But even with the best defenses, some breaches are inevitable.
Right.
That's where our biocides and our monitoring systems come in.
Precisely. It's a multifaceted approach. Prevention, monitoring, and targeted treatment. We need to be constantly vigilant,
Right.
adapting our strategies as the biofilms themselves evolve.
It's a constant arms race.
Yeah.
We develop a new weapon, they adapt.
Yeah.
We come up with a new strategy, they find a way to circumvent it.
That's the fascinating thing about this field. It's constantly evolving. We're always learning new things about biofilms,
Right.
about how they form, how they behave,
Right.
how they resist our attempts to control them.
Yeah.
And with every new discovery,
Mm-hmm.
we gain a deeper understanding of how to effectively manage them.
So we're not just fighting a war against biofilms, we're also engaged in this constant dance, this intricate back and forth between our efforts to control them
Right.
and their remarkable ability to adapt and persist. Are there any other promising strategies in development?
There's a lot of research focused on enzymatic treatments. These are biodegradable and highly specific,
Okay.
meaning they can break down biofilms without harming the surrounding environment
Right.
or contributing to resistance.
So we're moving toward a more holistic and sustainable approach to biofilm control.
Precisely. We're recognizing that biofilms are a complex problem.
Right.
That requires complex solutions.
What's the key takeaway for our listeners?
The key takeaway is this: Biofilm monitoring is not optional. It's essential. It's the only way to truly understand the scope of the problem,
Right.
target our treatments effectively,
Mhm.
and ultimately protect our health, our infrastructure, and our environment.
It's about moving from a reactive approach to a proactive one,
Oh,
understanding that biofilms are a constant threat
right.
that requires our vigilance and innovation.
Exactly. We need to stay informed, embrace new technologies,
Okay.
and adopt a holistic approach to biofilm control.
This has been a fascinating deep dive into the hidden world of biofilms.
Mm-hmm.
It's amazing how these microscopic communities can have such a profound impact on our lives.
It's a world full of complexity and wonder. And as we've learned today, it's a world that we can't afford to ignore.
Well, thank you for joining us on this journey. We hope you've gained a deeper understanding of these bacterial fortresses and the ongoing battle to keep them in check.
It's been my pleasure.
Until next time, keep exploring, keep questioning, and keep diving deep into the fascinating world of science.
And remember, knowledge is power, especially when it comes to those sneaky little biofilms.
Absolutely. See everybody next time.